All right, so we've all been hearing about mRNA vaccines, right? But how do they actually work? Well, today, we're going to pull back the curtain on the amazing science that basically turns your own body into a vaccine-making machine. Let's dive in.
It all kicks off with that familiar moment, a shot in the upper arm. But what happens right after that is a pretty incredible biological story. We're going to follow the journey of this vaccine step by step inside your body to see exactly how it gets you ready for a fight, but without ever putting you in any real danger.
So, what is it that makes this technology so different from the vaccines we're all used to? Well, the secret isn't really in what it is, but in the super clever message it delivers to our cells.
Okay, so traditional vaccines, they often work by giving your body a weakened or maybe an inactive piece of a virus. It's like showing your immune system a mugshot of the bad guy. But mRNA vaccines, they play a totally different game. They don't have any part of the virus in them at all, not a single piece. Instead, they deliver a very precise set of instructions, a little piece of code called messenger RNA, or you guessed it, mRNA.
Now, to really get how that message works, we first need to look at this amazing process that's already happening inside of you, right now, in trillions of your cells. Your body is basically a construction site that never closes. And inside every single one of your cells, you've got the machinery to read genetic blueprints and build the proteins that keep you going. And mRNA vaccines, well, they cleverly tap into this natural system for their own mission.
Think about it like this. Your DNA, that's the master blueprint for your entire body, and it's kept super safe inside the cell's nucleus. When your body needs to build a specific protein, it makes a temporary copy of just one small section of that blueprint. That copy is the messenger mRNA. The mRNA then leaves the nucleus and goes out to these little cellular factories called ribosomes, which read the instructions and bam, they start building the protein.
So, that process of reading the mRNA to build a protein, it's called translation. And it's happening all the time. Now get this, viruses have figured out how to hijack this exact system. They sneak their own genetic code into our cells and trick our ribosomes into building more and more viruses for them. Pretty sneaky, right?
But what if you could use that same system for good? What if you could give your cells the instructions to build just one tiny, harmless piece of the virus, just for target practice? Well, that is the genius idea here.
And this is absolutely crucial. The mRNA in the vaccine doesn't have the code for the whole virus. No way. It only carries the instructions for one very specific and totally harmless part, that famous spike protein. By itself, this protein can't make you sick. It's just a decoy.
So, once that mRNA gets inside your cell, it just hangs out in the main area, the cytoplasm. It never, ever goes into the nucleus, and it doesn't mess with your DNA. Your ribosomes find it, they read the code, and they start churning out those harmless little spike proteins. And, this is super important, after the job is done, your cell just breaks down and gets rid of the mRNA. The instructions are completely temporary. They deliver the message, and then they're gone.
Okay, so your cells have now made a bunch of these harmless spike proteins. This is where your body's security team, your immune system, finally gets to enter the story.
This really is the big question, isn't it? What's the point of all this? Well, the whole point is to give your immune system a sneak peek of the enemy, a preview, without ever having to go through a real dangerous fight.
The moment these spike proteins show up, your immune system goes, "Whoa, what is this?" It recognizes them as foreign invaders. It sounds the alarm and starts building powerful antibodies designed to neutralize them. But maybe the most important thing it does is create memory cells. These cells are like a permanent record, storing the blueprint of that spike protein. It gives your body a massive head start for any fight in the future.
This whole training exercise has a scientific name. It's called the adaptive immune response. Your body has officially learned how to spot the bad guy. So if you ever run into the real virus, it's not a surprise attack. Your immune system is already armed. It's got the intel, and it's ready to fight it off fast.
All right, now that we've got the how down, let's tackle some of those big practical questions that, a lot of us have about this technology.
And it's a totally fair question. If this approach is so brilliant, why does it feel like it just appeared out of nowhere during a global pandemic?
Well, the truth is, scientists have been working on this for decades. For years and years, they ran into this one huge problem. mRNA is incredibly fragile. Our bodies are designed to destroy it almost instantly. The absolute game changer was something called a lipid nanoparticle, which is really just a fancy term for a tiny protective bubble of fat that shields the mRNA on its journey to your cells. And by the way, that fragility is also why some of the vaccines need to be kept at those crazy cold temperatures to keep that message stable.
So what's the big appeal? Speed and scale. Unlike old-school vaccines that might require actually growing live viruses, which takes forever, mRNA can be designed and printed out in a lab using common materials. This makes the whole process way faster, easier to scale up, and cheaper, all things that are absolutely critical when the whole world needs a solution at once.
Of course, none of that speed or cleverness really matters if the technology isn't safe. So let's take a look at what the actual data from the early trials showed. So this is the number to remember. In the initial big trials for these vaccines, about 70,000 people were involved, and the data from those massive studies came back clear. No serious safety concerns were reported. And that's the entire reason you do testing on that kind of scale.
Now, we've got to be really clear here. Safe does not mean zero side effects. A lot of people definitely reported things like aches, a sore arm, or feeling tired. And of course, most of these vaccines need 2 shots to really get the job done. But those feelings, they're often a sign that your immune system is firing up and doing exactly what we want it to do.
I love how the vaccine researcher, Professor Shane Crotty, put it. He said, "A bit of pain can be a positive sign that good things are happening. Sometimes you have to earn your immunity, just like you have to earn those biceps. That feeling you get, that's your body building up its defenses."
So when you boil it all down, the process is just incredibly elegant. Instead of us having to fight a virus head-on, we're just giving our body the right information so it can protect itself. It's a technology that stands on the shoulders of decades of research, and it lets us respond to new threats faster than ever. Which kind of leaves us with a pretty cool question. What else could we teach our bodies to fight next?